In this video, we're going to check out bubble sort. Before we observe what bubble sort does, let's have a look at the code and have a little look at a few facts here, so it gives you an understanding of what's going on. Bubble sort, the passes equals n minus 1. So the number of passes that it's going to pass through the list in order to be able to sort it is going to be whatever the length of the list is minus 1. So if it's 8, it's going to make 7 passes. The swaps, and this is the worst case scenario, is half n squared minus half n. And I will show you how I arrived at that answer in a little while. Its naive sorting and its complexity is O n squared. It's got 2 for loops there, which is n times n equals n squared. Now, if we have a look at the first for loop, you'll notice that we have the length of the list minus 1. Now, the reason for this is you don't want to iterate over the last item in the list, because once you get to the for loop, the second for loop, you're going to get an error because there's no adjacent item for it to be compared to, which is what the if a list I is greater than a list I plus 1 is about. So what it's doing is it's saying for pass, make the first one excuse me, make the first one less than the length of the list. So if our list is 8, then pass is going to equal 7. And each time it goes through this loop, it's going to decrement by 1, and it will stop when it gets to 0. So when it goes through the first loop, pass equals 7 if we've got 8 in our list. For the second loop, for I in range of pass, so pass is going to be 7, so I will start at 0 and it will stop at 7. And it will keep going through this piece of code until I equals 7. What's going on in the second for loop is there's being a comparison is being made. So if we take I as being 0, it will compare it to what I plus 1 is. So that's going to be whatever is in index 1. So it compares 0 to index 1, or index 0 to index 1, and then it will run the following code. If it's greater, it will put it in a temp. It will then swap the items around and then move on to I equals 1 and compare index 1 to index 2 until it gets all the way to 7. The next, once it does get through to 7, it will go back into the first for loop, and pass will then be 6, and it will do the same thing again. This is a regular bubble sort. What's going to happen is we're going to check the first elements, and then we're going to move up 1 and check the next 2 adjacent elements, and then move up 1 and check the next 2 adjacent elements, etc., all the way through the list. Each time we pass through the list, we're going to shorten the amount that we check by 1. That's what the n minus 1 is about. The next time it will be n minus 2. The next time we pass through will be n minus 3. See as we go along. The reason why we go through the length of the list minus 1 is because we're checking adjacent items. So once we get to this one, there is no adjacent item to check. So we get here, we check these. This is going to be minus 1. So 1 from the end of the list. So let's get started. First of all, we check the first two elements. 23 is greater than 1, so we swap and move up 1. Then we check the next two elements. 23 and 45 are in the correct position, so we leave them alone and move up. We check 45 against 2. 45 is greater than 2, so we swap and move up 1. We then check 45 against 27. 45 is greater than 27, so we swap and move up 1. We then check 45 against 18. 45 is greater than 18, so we swap and move up 1. Then we check 45 against 3. They're out of position, so we swap. And notice that the highest number in the list is at the end here. That's why it's going to be n-1, because we won't need to check that anymore. It's effectively in a sorted portion. We go back for a second pass. We check 1 against 23. They're in the right position, so we move up 1. We check 23 against 2. They swap because 23 is greater than 2, and we move up 1. We then check 23 against 27. They're in the right position, so we leave them alone. We move up 1. We check 27 against 18. 27 is greater than 18, so we swap and move up 1. We check 27 against 3. 27 is greater than 3, so we swap, and we're done for that pass. We then move back to the beginning. We check 1 against 2. They're in the right place, so we leave them alone and move up 1. We check 2 against 23. They're in the right place, so we leave them alone and we move up 1. We check 23 against 18. 23 is greater than 18, so we swap and move up 1. We check 23 against 3. 23 is greater than 3, so we swap, and then we move back to the beginning of the list. We check 1 against 2. They're in the right place, so we leave them alone. We move up 1 and check 2 against 18. They're in the right place, so we leave them alone. We move up 1. We check 18 against 3. 18 is greater than 3, so we swap. And then we're done for that pass. We then check 1 against 2. They're in the right place. We then check 2 against 3. They're in the right place. We go back. We check 1 against 2. They're in the right place. And we're done. At the beginning of the video, I said to you that I was going to explain how I got half n squared minus half n for the formula for the maximum amount of swaps in a worst case scenario. So if we look at a worst case scenario, if we have 6, 5, 4, 2 and 1. This is a worst case scenario because all of the items are out of order. We know that the passes equals n-1, so that's 6 minus 1. Whoops, not 6 equals 1. That doesn't work. 6 minus 1 equals 5. So each time we pass through this list, there's going to be a number of swaps. So the 6 is going to swap with the 5. I'll get it right in a minute. The 6 is going to swap with the 5. So these are the swaps. Yeah, and then it moves on to the next one and checks this with this. So it makes another swap there. 'Cause 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 ' and then we have a third swap. The 6 and a 3 swap round. And then we have a fourth swap. And then we have a fifth swap. The 6 is checked with the 1 and it swaps. So by the time you've got through, if we call this pass 1, by the time you've gone through pass 1, you've already made 5 swaps. If we were to go through it again, you would make 4 swaps, and it would keep on going down until you got to 1. So the swaps also equal n minus 1. Right, so what can we do with this information? Well, if we look closely at this list here, it's an arithmetic sequence. So we can use the formulas in arithmetic sequence, but we want to add up how many swaps are happening. So there's a formula to do that, which is n times a sub 1 plus a sub n divided by 2. So if we call the first swap n minus 1 and the first pass n minus 1, the second pass n minus 2, the third pass n minus 3, the fourth is n minus 4, and the fifth is n minus 6. N minus 5, I'm sorry, that's pretty awful, isn't it? So these are the passes. The swaps, there was, for n minus 1, we had 5 swaps. For n minus 2, there would be 4, and then it would be 3, and then it would be 2, and then it would be 1. And we want to add these together. Now, this is pretty easy to add together, but if you had lots of numbers going into the list and they were all out of order, you want an easy way to be able to do it. So we can use this formula. This n here represents the number of items in a list. Well, we don't quite want that. We want the number of passes, so we can swap n minus 1 in there. The a sub 1, this is going to be a sub 1, this is a sub 2, the last one is a sub n. So that is n minus 1 as well, because the number of swaps is also n minus 1. And then it is going to be plus 1, because the last one is going to be, it doesn't matter what it is, how many numbers you've got in your list, it's going to have, it's just going to have 1 swap. So the first item in the list is this one, and this is all, of course, divided by 2. The first item is this one, the last item is this one. Now, if we do a bit of algebra, we do use FOIL, and we can have n times n is n squared. N times minus 1 is minus n. Minus 1 times n is going to be minus n. Minus 1 times minus 1 is plus 1. Then we have n times 1, which is plus n. And then we have n, minus 1 times plus 1, which is going to be minus 1. And that's all divided by 2. So this is the formula for the swaps. Equals this. Now, if we look at this a little closer, we can see we've got two n's here, we've got three n's. This is a plus n, and one of these is a minus n. So we can swap one of these minus n's out because minus n plus n is going to be 0. And it's the same for these constants here. Plus 1 minus 1 is 0, so we can just cancel those out. And what we're left with is n squared minus n divided by 2. Now that can be rewritten as a half n squared minus a half n, and this is the answer. So if we put some real numbers in now so that we can see what's going on. We have we worked out the swabs, we've worked out the passes, we've worked out the formula, and we had 6 items in our list. N equaled 6, and we have n squared here. So we've got 6 squared minus 6 divided by 2. This equals 36 minus 6 divided by 2, which equals 15. Okay. Now to check that against this, what have we got? We've got 5 plus 4, so that's 9. And then we've got 9 plus 3, that's 12. And then 12 plus 2, that's 14. And 14 plus 1, which is 15, which is the same answer that we got over here. So our formula does work. To summarize, bubble sort is a short piece of code that has a nested for loop, that's a for loop inside of a for loop, which gives it the O(n) squared. It literally bubbles up larger items, larger values in the list to the end of the list, and smaller items to the beginning of the list. It checks adjacent items one against the other and makes swaps. The number of passes it will make equals n minus 1, and the swaps for worst case scenario equals half n squared minus half n. Now, the criticisms of bubble sort is that it's slow. Okay, so bubble sort is slow. And the reason why it's slow is because for smaller values, it's okay. But if you're having to increase n, if you're increasing n here, that's quickly going to get very, very large. So values of n and these are resources It's going to look like this on a graph. It's going to start off quite sort of small, and then it's going to get bigger and bigger and bigger and bigger and bigger and bigger. The more value, the higher the value of n becomes. Bubble sort is not only slow. Towards the ends of the algorithm, it seems to check things that are already in order, and that just seems to be a waste of time and resources.
If you liked this video, give it a thumbs up and try out one of my other videos.